Hello and thank you for watching my video. My name is Astrid Krasniqi. I'm CCNA and CCNP certified instructor. On this video we are covering CCNA Semester 2 Routing and Switching Essentials. This is Chapter 9 Access Control List. Chapter 9 is divided in 5 sections. Section 9.1 IP Access Control List Operation. Then Section 9.2 Standard IPv4 ACLs. Then we have Section 9.3 Extended IPv4 Access Control Lists, Section 9.4 Troubleshoot ACLs, and 9.5 IPv6 ACLs. 9.1 IP ACL Operation or IP Access Control List Operation. Upon completion of this section, you should be able to explain how ACLs are used to filter traffic, compare standard and extended IPv4 ACLs, explain how ACLs use wildcard mask, explain the guidelines for creating ACLs, and explain the guidelines for placement of access control list. What is an access control list? By default, a router does not filter traffic. As they come into the interface, the router will look at the destination IP address on the packet and it will find out in the routing table, do I know where to go, what interface I need to exit, and that's it, and it will move it on. With the access control list, we can filter some traffic that we want to permit to go through our interfaces or to go through our router, and we want to maybe deny some kind of traffic to go through our router. So when an access control list is applied to an interface, the router will evaluate all network packets and it will determine if the packet is permitted or denied. An access control list is a sequential list of a permit and deny statement known as access control entries or ACEs. So you can create as many entries on that ACL. The router will read them all entries one by one from the top to the bottom and try and match. If there's a match, then it's going to either do whatever the match says, either permit or deny. If there's no match, then it's going to be a deny, which is implicit deny. So access control entries, or those statements that we type in, are also known as access control list statements. Access control list controls whether that router permits or denies packets based on the criteria in the header that identifies the source IP address and destination IP address, IP protocol, ICMP, TCP, UDP, EIGRP, OSPF, any other protocols, TCP and UDP source port number and destination port number. A router acts as a packet filter when it forwards or denies packets according to the filtering rules. So what we're doing with ACLs, we are creating these filtering rules, whether we allow some traffic or deny some traffic. We create them on the statements, right? There's a sequential list of each one has a statement. These are called access control entries. Like few access control lists, few statements that will create that list. The list, we configure it on the global configuration mode. Doesn't really have that much effect until we apply it on one of the interfaces as incoming or outgoing ACL. Once we apply it to the interface, then the router is going to look at that list whether it allows or denies the traffic. ACL operation, so we have inbound ACLs, access control list, as they come into the router. An inbound ACL filters packets coming into a specific interface and before they are routed to the outbound interface. Outbound ACLs, it filters packet after being routed, regardless of the inbound interface. So as the packet they come in to the router, we can have an ACL there, either permit or deny. Or we can let the packet being routed, right? And as they are leaving the interface, we can say, okay, well now they are permitted or denied. So it's depending on the situation, but you really maybe want to filter them here because you don't want the router to do everything, all his thinking, and then just find out, oh, I'll have to drop that packet actually. But anyway, different situation that will require at a different point you configure the inbound or outbound. The last statement on ACLs is always implicit denied. And now this statement is hidden. You're not going to be seeing it, but it's there. This statement is automatically inserted at the end of each ACLs, even though it is not physically present. The implicit deny will block all the traffic. Because of this implicit deny, an ACL that does not have at least one permit statement will block all traffic. So, with access control list, like I want you to imagine that you create an ACL for brand new restaurant that you have open or something. Now you will gonna allow some people to come in to your bar and maybe specifically deny some people because they're troublemaker. You don't want to cut them to come in your bar. So you say, okay, well this group of people are allowed, this group of people are allowed, this person and this person are denied, definitely don't let them in, and you hand it to the person at the door. Now the doorman is going to look at that list and say, okay, well, as soon as a person comes in, somebody comes in, it's going to look at the list, and if you match somewhere in the list, it's going to react to whatever that match says. If it matches permit, he will let them in. If it matches deny, he will deny them. But if you don't match anything on the list, what is the domain going to do? Let them in or out? Right? It's going to deny. So that's your implicit deny. So the last statement, even though it's hidden, it's called implicit deny. There's two types of ACLs. So we have a standard ACL. A standard ACL can permit or deny traffic for source IP address only. So only they look at the source address. As the packet come in, router will read the source address, where is it coming from, and then either permit or deny based on that only. Or we have an extended ACL, where with the extended ACL, we can permit or deny traffic for protocol type. So depending on what protocol they are using, IP, ICMP, EIGRP, OSPF, TCP, UDP, or whatever. We can look at the source IP address, or we can look at source TCP or UDP port numbers. We can look at the destination IP address, or destination TCP or UDP port numbers. So a bit more involved. So in the standard ACL, looks at the source only. Extended ACL, a bit more involved, looks at more fields. Okay, don't worry about these because we're going to talk a lot more about them, how they are creating ACLs, and this is an extended ACL. So you can see the standard ACL, for example, permit, and we only permit in network from this source. So 192.168.30, because that's our wildcard mask, so we are matching those 3 octets. So say anything that starts with 192.168.30, we're going to permit it. If packet comes in with the network address, source address 172.16.11, that's going to be denied because we have implicit deny here in the end. And you can see in extended ACL, we are permitting, for example, with the TCP protocol. So any network, any packet comes in from that network with the TCP, and the same, the wildcard mask, the whole thing is, it's one statement. That network with that wildcard mask going anywhere, and as long as they're using port 80, we are going to permit them, right? Equal to port 80. That's a destination port. So numbered and named ACLs. So if we still have two ACLs, we have a standard or extended ACLs, but we can have numbered standard and extended ACLs, or we can have named standard or extended ACLs. If we have numbered ACLs, so we have from number 1 to 99, these are the standard ACL, 1 to 99, or from 1300 to 1999. This is not N2, I would say 2. So there's another 700 ACLs. Or we can have from 100 to 199, or 2000 to 2699. So these are your standard ACL and extended ACL. So standard 1 to 99. So like this, if you went early, access list 10. This fits on the somewhere here. So that means that it's a standard ACL. Or you can say access list 1300 here. That will be standard as well. Yeah, so that's a standard ACL. Access list 100 to 199. These are called an extended ACL. So if I go back, this is 1 and 3. So that means it's an extended ACL. Now, when these were the beginning, only these numbers that were available, and the ISPs and so on, they looked at it and said, okay, well, that's not enough, definitely not enough. So they created another range, and it still wasn't enough. So they created a named ACL. So now there's no numbered, you can just name them, and there's no limit to how many ACLs you can create with a named ACL. You assign a name by providing the name of the ACL. Names can contain alphanumeric characters. It is suggested that the name be written in capital letters, so your ACL should be in capital letters. Well, recommended. Names cannot contain spaces or punctuations. You can add or delete entries within an ACL. a wildcard mask. So standard and extended ACL, both they do use a wildcard mask. A wildcard mask and a subnet mask differ in the way they match binaries 1s and 0s. So wildcard mask uses the following rules to match binary 1s and 0s. So wildcard mask bit 0 means match the corresponding bit value in the address. Wildcard mask bit 1 means ignore the corresponding bit value in the address. If I open a notepad, and I'm going to explain a bit more about wildcard mask here. Oh yeah, we were looking at chapter 8 as well, the wildcard mask. Okay, so for example, say the address 192.168.1.0, yeah, you want to permit this network, yeah, 192.168.1.0. The network is say the address, the subnet mask address is 255.255.255.0. Easy way to find out the wildcard mask is get the subnet mask, take the subnet mask, right? Take the subnet mask and put 255, 255, 255, 255 in the top and minus that subnet mask, and that will give you the wildcard mask. So right, so very quickly you can see the wildcard mask is like inverse of your subnet mask, but it's not like subnet mask, nothing to do with the subnet mask. Okay, so that will be your wildcard mask. You put it here. Just fix it a little bit. There you go. We permit 192.168.1.0. We are matching the first 3 octets, so we are matching 192.168.1 network, and last octet any number can be. So if you get a packet comes in, for example, with address 192.168.1.55, that's going to be permitted or denied. Well, because the first 3 octets they do match, right? So that's going to be permitted. So if I write down a P there, well, never mind, small p there. If say an address comes in now for say 200, again, because the first 3 octets they do match with our statement, that's going to be permitted. If I put here 20 to 200, the third octet is different. It should be 1. That's what we say, and that's going to be denied. Right. So if I give you another wildcard mask, so for example, let's say we want to permit anything that starts with 192. It doesn't matter what is the middle number, and they need to have 200 here, and doesn't matter the 4th number. So what will be our wildcard mask? So that's what I'm trying to say to you, that it's not the same as a binary, subnet mask. So for wildcard mask will be permit 192, and then we don't really care about the second octet, so that will be all 1s, right? 255, and then we want to make sure we match the third octet, which is 200. So we match that, and we don't care about the last octet, so 255. So you remember the subnet mask, we used to say 1's on the left, the 0's on the right, so it had to be, it couldn't be like the 0, 255, 0. Can't have that with the subnet mask. But wildcard mask, yes, we just want to permit the first octet, match the first octet, match the third octet, but ignore the second and ignore the third, the 4th. So if I have an IP address, a packet that comes in with address 192.200, say 123, 200.123 again, this is going to be permitted because we match the first octet and we match in the third octet. It doesn't really matter what I put here, what numbers I put here, right? So for example, say permit, let's say first octet I don't care, second octet I don't care, third I don't care, and the 4th I want it to be IP address 10, right? So anything that starts with 10, it's got last octet 10, I don't want to, maybe I want to permit them. So the wildcard mask will be 255, 255, 255.0. That's a wildcard mask. It's not a subnet mask. Oh, maybe I did confuse that a little bit. But all I want you to know, the wildcard mask, it just defines what is permitted and what is ignored. Oh, sorry, what is matched and what is ignored. So 0 is a match. 0 means a match, and 111 1s means ignore. So 255, 255. Okay, so for now, until you become expert at this, we look at that like this. So we can subtract our subnet mask from all 255s. So for example, our subnet mask is /24. That will be our wildcard mask. If the subnet mask is ends with 240, then that will be our wildcard mask, .15. If our subnet mask ends with 252.0.0.0, then it will be 0.0.3.255. So calculating wildcard masks can be difficult, but you can do it easily by subtracting the subnet mask from all 255s. Again, the same thing we talked about. So that's the subnet mask. So access list 1 permit, wildcard mask 192.168.3.0 0.0.0.255. Assume you wanted to permit access to all users from that network, then you'll put your 255s on the top minus your subnet mask, and that will give you the wildcard mask. A host keyword, for example, if you want to permit a single host, so access list 1 permit 192.168.1.1. So we want to match the first octet, we want to match the second octet, third octet, and fourth octet. We want to match the whole thing, yeah? We want to match the whole IP address. Now, we don't have to do this. We can replace all these zeros with a host. So instead of putting all these zeros, we'll put the host. But we'll put the host in front. Yeah, like here. I'll put a small h there if I can. Okay. So the wildcard mask all zeros, and then result is 192.168.1.1. So the host keyword can be used to substitute for the zeros wildcard mask. This mask states that all IPv4 address bits must match, or only one host is matched. So access list 1 permit, so host first, and then the IP address of the host, instead of putting the 4. It's the same thing. You can do it this way, but this way it doesn't make sense more when you quickly look at it, what you permitted. So the wildcard mask, again, if I just go here, see it's zeros and ones. It doesn't really matter where you put these zeros and ones. There's not a rule like in subnet mask where ones they have to be here and the zeros they have to be here and so on. The wildcard mask, you can just change 1 here. Say, okay, well, I want that to be ignored. And 0 means match, but this one maybe I wanted to ignore. Everywhere they put ones, it just means that ignore that bit. A host keyword can also be used in IPv6 access control list. Any keyword, for example, if we match anything, we don't really mind whatever the network comes from, we put all 255s. It doesn't matter what number you put here. You can put 1, 2, 3, 4 if you want. It just says that, okay, ignore the first octet, ignore the second, ignore the third, and ignore the fourth. Match everything. Right? So here, that's your, see, we have all the ones that we don't, we ignore. So the any keyword can substitute for the 255, 255, 255, 255 wildcard mask. This mask says to ignore the entire IPv4 address or to accept any address. But we can change that very, very easy, simple. Instead of writing all this information down, it's going to take a long time. Just put any. Okay. The any keyword can also be used in IPv6 ACLs as well. So examples of wildcard mask keywords. So for example, you can say access list 1 permit, and we permit in anything. It doesn't matter here what number you put. You can put any number you want. But here we are saying ignore the first octet, ignore the second, ignore third, and ignore fourth. So that is permit any. Or you can just say if you want to match the whole, match the first octet, second, third, and fourth, match them. That means we are matching a single host. Okay. General guidelines for creating ACLs. Use ACLs in firewalls, routers positioned between your internal network and an external network, such as the internet. Well, that's most of the time where we put our ACLs, in our router where we connect to the internet. Use an ACL, access control list, on the router positioned between two parts of your network to control traffic entering or exiting a specific part of your internal network. So you don't have to just put it on the where you connect to the internet. You can put it between the two part of the networks. Maybe financial team, you want to control it with ACLs, people accessing those computers. We can configure an ACLs on a border router that is a router situated at the edge of your networks. Configure ACL for each network protocol configured on the border router interfaces. The guidelines for creating ACLs are, we have 3 P's that you won't need to remember. We have one access control list per protocol. To control traffic flow on an interface, an ACL must be defined for each protocol enabled on the interface. One ACL per direction. An ACL control traffic is one direction at a time on the interface. 2 separate ACLs must be created to control inbound and outbound traffic. And 1 ACL per interface. An ACL control traffic for an interface, for example, gigabit Ethernet. So if I write it here for okay, say I have a router here. This router has got one interface. So how many ACLs can I create? Well, I can create 1 per protocol. So if I'm running, for example, say I'm running IPv4, just IP, that says IPv4. Now we can create 1 access list per protocol per direction. So we can say 1 going that way and 1 coming this way. That's 2 directions, outgoing and incoming. So per protocol and per interface. So that's our interface. So how many access lists? Well, 2 if we just run an IP. If, say, let me change the color here. Let's put this, if it makes a difference. IPv6 here. Say if I have an IPv6, I can have two more ACLs. I can have 1 more going that way, that's IPv6, and 1 more coming this way, that's IPv6. So we can have 4 in total. So ACLs is 1 per protocol per direction per interface. So 1 right here, 1 per protocol per direction and per interface. So if you have 1 interface like this and 2 protocols, we can have 4 in total. Think about this, yeah. If I have, say, 1, 2, 3, 4 interfaces, so I have 4 interfaces. So how many ACLs? Okay, I'll let you think about it. I don't know, maybe send me an email with the answer. Okay, general guidelines for creating ACLs. So with 2 interfaces and 2 protocols running, this router could have a total of 8 separate ACLs. So again, you have to remember, we have to have 1 ACL per protocol, per interface, and per direction. So guidelines, ACL Best Practices. Base your ACLs on the security policy of the organization. This will ensure you implement organizational security guidelines. Prepare a description of what you want to do, what your ACL want to do. This will help you to avoid inadvertently creating potential access problem, and this will help you to, for example, if I come in your work after 6 months or you leave and somebody else comes in, if there's a description of your ACLs, they will know what you were trying to do. Use the text editor to create, edit, and save ACLs. This will help you to create a library of reusable ACLs. And test your ACLs on development network before implementing them on production network. This will help you to avoid any costly errors. Where should we place an ACL? That's a big question. Every ACL should be placed where it has the greatest impact and efficiency. The basic rules are: extended ACLs, locate extended ACLs as close as possible to the source of the traffic to be filtered. Standard ACLs, because standard ACLs do not specify destination address, place them as close to the destination as possible. Placement of ACL, and therefore the type of ACL used, may also depend on the extent of the network administrator control, bandwidth of the network involved, and ease of configuration. So for example, if we have a standard ACLs, where would you place them? So standard ACL, because standard ACL do not specify the destination address, place them as close to the destination as possible. Placing standard ACL to the source of the net traffic will effectively prevent that traffic from reaching any other networks through the interface where the ACL is applied. So think about, okay, we want this network not to access this network. So 192.168.10.0 not to access 192.168.31.0. Now, in what you need to do because it's a standard ACL, we need to place them as close to the destination as possible. So this here, as they're going out here, we want to place them there. Why don't we place it here? Because even though we deny in this one, because we look at the source only, that will be denied everywhere. That will be denied to go here, that will be denied to go somewhere else, maybe to go to his side. So for that reason, we need to place them as close to the destination as possible. We don't even place them there, because if we place them there, then they will be denied to going on this network as well. Because we only look at the standard ACL, we only look at the source address. Extended ACL placement. So here, because we know the source and destination, the protocol, everything, we can place them as close as possible to the source. So extended ACL, this way, undesirable traffic is extended close to the source network without crossing the network infrastructure. So you place them as close to the source as possible. Thank you very much for watching this section 9.1 IP ACL operations. Please have a look at my other videos and don't forget to subscribe. This has been Astrid Krasniqi, and next video 9.2 standard IPv4 ACLs. Bye bye.